In this video, you will learn about chords and arcs of circles. First, let's discuss some key terminology. A chord is a segment whose endpoints are on the circle. So if we look at the diagram below, the endpoints A and B are on the circle, so AB is an example of a chord. Now the theorem below tells us that within a circle or congruent circles, that congruent central angles have congruent chords have congruent arcs, and congruent arcs have congruent central angles. So essentially it's telling us that if we have congruent chords, arcs, and central angles, that these kind of all work together and mean that they are all congruent to each other. So for example, in this diagram, it says that given that arc BC is congruent to arc DF, what can you conclude? This allows us to say that since it's given that the arcs are congruent, then you can conclude the two other relationships. So the first relationship we have is that the chords are congruent, and the second one is that the central angles are congruent. So if I were to list out my chords are congruent, the chords that we're talking about are chord BC and chord DF. So we could say that segment BC is congruent to segment DF, and then the central angles they're talking about is the angle formed by the vertex. So it would be angle BOC is congruent to the other central angle, so angle TPF. So again, using what we know, and since the circles are congruent, we can conclude the other two relationships. Now the next theorem says that within a circle or congruent circles, that chords equidistant from the center are congruent, and congruent chords are equidistant from the center. So if we have this given distance from the center is congruent, then we can assume that the chords are congruent. So in this case, we would have that chord WX is congruent to chord YZ. And similarly, if we have the chords are congruent, you could say that they're equidistant from the center. Now, if we apply this in an example, we have that the two smaller parts of both these chords are congruent. So we could say that the full chord for these two is congruent as well. Now, since the full chord is congruent, we can further conclude that they're equidistant from the center, meaning that the length of x and the length of h should be the same, so you can conclude that x should equal 8. Similarly, here we have the distance from the center is congruent because they both have a length of 4. Now that means that the length of the chord should be congruent. Now since QR is 7 and it's marked that RS is congruent to it, that means that this side is also 7, and we know that 7 plus 7 gives us a value of 14. So the length of QS is 14, which means that AB is 14 as well. So your answer is that AB equals 14. Now the next theorem tells us multiple things. First, it says that in a circle, a diameter that is perpendicular to the chord bisects the chord and its arcs. In a circle, a diameter that bisects a chord that is not a diameter is perpendicular to the chord. And then lastly, the perpendicular bisector of a chord contains the center of the circle. So essentially, whenever you have some sort of perpendicular bisector as shown below, you know that it's going to go through the center of the circle. Now, a real-world example of where you may see this is with a flat tire. The example says the center of the tire is located on the perpendicular bisector of the flat part. Because the flat part of this tire is this chord of the circle, as shown below, and the perpendicular bisector would be this part, which will go right here and splits in half, making the right angle. Now, in such an example, since we have a segment that's on the center and it splits the chord in half, that allows us to know that this is going to be perpendicular because it's a perpendicular bisector. So now, looking up above, I have a right triangle where I had a side that was 11, 15, and y. So I can solve using Pythagorean theorem. So if I have a squared plus b squared equals c squared, again, my value of c is whatever's across from the right angle. So 15 is c, allowing us to say 11 squared plus y squared should equal 15 squared. So it gives us 121 plus y squared, and 15 squared gives us a value of 225. If I solve for y squared, it gives me y squared equals 104, and then you take the square root of both sides, gives us a value that y equals 10.2 as your final answer. Now in the next example, it says P and Q are points on a circle. The distance from the center O to PQ is 15 inches and PQ is 16 inches. Find the radius of the circle. Now, since this is the distance from the center to a chord, we know that this is a right angle and this chord is split in half. So if I took the 16 and split it in half, would give us a value of 8, meaning that this length is 8 and this length is 8. And now, if I want to solve, I have a right triangle as shown here. So if I redraw my right triangle, I have, this is 8, 15, and r. And whatever's across the right angle has to be that value of c. So in this case, it's going to be r. So if I use a squared plus b squared equals c squared, gives you 8 squared plus 15 squared equals r squared. So if I add 8 squared plus 15 squared, gives you a value of 289 equals r squared. And then if you take the square root of 289, it gives you a value of 17. So the length of the radius, or r, is 17. Now, in an example such as what's given here, it's asking us for the value of st in the circle. Now, since we know that the distance from one chord to the center is 5, and they're marked as congruent, that means that this distance is also 5. Now, it also tells us in the given that the radius of the circle is 8 centimeters. So let's say I draw in a radius from the center to the edge of one of the chords, and this has a length of 8 centimeters. We'll see now, looking at this, we have a right triangle. Because if I were to call this length x, I could redraw this as just the right triangle. So I have a side that's 5, 8, and x. So if I use Pythagorean theorem, again, the value of 8 is going to be my c value. So I'd have x squared plus 5 squared equals 8 squared. So you get x squared plus 25 equals 64, which gives you x squared. If you do 64 minus 25, gives you a value of 39. And then if you take the square root of both sides to solve, the square root of 39 gives us a value that x equals 6.24. Now this means that this part of the length is 6.24. However, because this is a chord and we know that it's equidistant from the center and it's perpendicular, we know it's split in half. So we could say that both of these lengths should be 6.24. So now I can determine that the whole length of the chord should be 6.24 plus 6.24, which when I double that, gives me a value of 12.48. So you should have that ST should equal 12.48. In our last example, it says a 9 centimeter chord is 11 centimeters from the center of the circle. What is the radius of the circle? So if I were to draw a diagram, I have a circle with my center. We know that we have a 9 centimeter chord. So I'm going to draw in a chord somewhere on the circle. So let's say I choose to draw in this chord right here. We know that the chord is 11 centimeters from the center of the circle. So we know that this distance is 11 centimeters. And it told us before that this whole distance was 9. Now, since this is a chord and that goes through the center, we can assume that this is going to be a right angle. And if I wanted to find the length of just that small part, or just half of the chord, then take that value of 9 and divide it by 2, which gives us a value of 4.5. So since these are both congruent, they're both equal to 4.5. Now the question is asking for the length of the radius of the circle. So if I draw in a radius of a circle, and I call it R, we can see that we have a right triangle, which I can redraw. So I have the radius, this is 11, and this is 4.5. So to solve with a right triangle, we're going to use the Pythagorean theorem. So a squared plus b squared equals c squared. Again, picking out that value of R as my value of c, because it's straight across from the right angle. So I can say that 11 squared plus 4.5 squared equals R squared. The 11 squared plus 4.5 squared gives us a value of 141.25 equals R squared. And then you can take the square root of both sides, and the square root of that 141.25 gives us a value of 11.88 equals R. So the radius is 11.88 centimeters as your final answer.